Hey guys! In previous video I had discussed briefly about adrenergic nervous system. Today I will be starting with adrenergic drugs. Let's begin. In today's session I will be giving a brief introduction about adrenergic drugs and then I will discuss the classification of adrenergic drugs. Classification of adrenergic drugs is very important. Let's begin with introduction of adrenergic drugs. Adrenergic drugs are also known as sympathomimetic drugs. Adrenergic drugs are also known as sympathomimetic drugs. Adrenergic drugs are the drugs whose action mimic that of sympathetic stimulation. They will produce the actions similar to that of sympathetic stimulation by acting on adrenergic receptors. Catecholamines, adrenaline and noradrenaline are adrenergic agonists. Catecholamines that are produced in body like adrenaline and noradrenaline are adrenergic agonists. Remember three things. Adrenergic drugs act on adrenergic receptor and produce the action similar to that of sympathetic stimulation. Adrenergic drugs are also known as sympathomimetic drugs, and catecholamines, that is adrenaline and noradrenaline, are adrenergic agonists. We are done with introduction of adrenergic drugs. Let's start with classification. Adrenergic drugs are classified under three headings. Adrenergic drugs are classified on the basis of chemical classification, on the basis of mode of action, and the third heading is therapeutic or clinical classification. Adrenergic drugs are classified on the basis of mode of action, chemical classification, and therapeutic or clinical classification. These are the three headings. Chemical classification of adrenergic drugs is on the basis of presence or absence of catechol nucleus. Chemical classification of adrenergic drugs is on the basis of presence or absence of catechol nucleus. On the basis of presence of catechol nucleus, adrenergic drugs are classified as catecholamines and non-catecholamines. On the basis of presence or absence of catechol nucleus, adrenergic drugs are classified as catecholamines and non-catecholamines. The examples of catecholamines are noradrenaline, adrenaline, dopamine, and isoprenaline. Isoprenaline is synthetic. The examples of catecholamines are noradrenaline, adrenaline, dopamine, and isoprenaline. The examples of non-catecholamines are epinephrine and amphetamine. The examples of non-catecholamines are epinephrine and amphetamine. Chemical classification of adrenergic drugs is on the basis of presence or absence of catechol nucleus. If catechol nucleus is present, then the adrenergic drugs are classified under catecholamines. If catechol nucleus is absent, then adrenergic drugs are classified under non-catecholamines. The examples of catecholamines are noradrenaline, adrenaline, dopamine, and isoprenaline. The examples of non-catecholamines are epinephrine and amphetamine. We are done with chemical classification of adrenergic drugs. Now we will discuss the classification of adrenergic drugs on the basis of mode of action. On the basis of mode of action, adrenergic drugs are classified as directly acting sympathomimetics, indirectly acting sympathomimetics, and mixed action. On the basis of mode of action, adrenergic drugs are classified as directly acting sympathomimetics, indirectly acting sympathomimetics, and mixed action. Directly acting sympathomimetics interact with adrenergic receptors and produce the actions of sympathetic stimulation. Directly acting sympathomimetics directly interact with adrenergic receptors and produce the actions of sympathetic stimulation. The examples of directly acting sympathomimetics are noradrenaline, adrenaline, dopamine, and isoprenaline. Directly acting sympathomimetics, they will directly interact with adrenergic receptors and produce the actions of sympathetic stimulation. Examples are noradrenaline, adrenaline, dopamine, and isoprenaline. Indirectly acting sympathomimetics causes release of noradrenaline from nerve terminal. Indirectly acting sympathomimetics causes release of noradrenaline from nerve terminal. As you all know, noradrenaline is a neurotransmitter of sympathetic nervous system. Noradrenaline goes and binds to adrenergic receptors and produces the sympathetic actions. I have used short form for adrenergic receptors. Indirectly acting sympathomimetics causes release of noradrenaline from nerve terminal. This noradrenaline goes and binds to adrenergic receptors and produces the actions of sympathetic nervous system. Examples are amphetamine. Example of indirectly acting sympathomimetics is amphetamine. Mixed action means there is both direct and indirect action. Direct action is by direct interaction with adrenergic receptors. Indirect action is causing release of noradrenaline from nerve terminal, which goes and binds to adrenergic receptors and produces the action. Examples are epinephrine and pseudoephedrine. We are done with classification of adrenergic drugs on the basis of mode of action. Now we will discuss the classification of adrenergic drugs on the basis of therapeutic or clinical classification. Vasopressors. The examples of vasopressors are noradrenaline and dopamine. The examples of vasopressors are noradrenaline and dopamine. The examples of cardiac stimulant are adrenaline and dopamine. The examples of cardiac stimulant are adrenaline and dopamine. The examples of CNS stimulant are amphetamine, epinephrine. The examples of CNS stimulant are amphetamine and epinephrine. The examples of bronchodilator is adrenaline, isoprenaline, and salbutamol. The examples of bronchodilator is adrenaline, isoprenaline, and salbutamol. The examples of nasal decongestant is epinephrine and pseudoephedrine. The example of nasal decongestant is epinephrine and pseudoephedrine. The example of uterine relaxant is salbutamol. The example of uterine relaxant is salbutamol. We are done with therapeutic or clinical classification. We are done with today's session. In next session, I will be starting the most important topic, that is adrenaline. Before watching the adrenaline, I will recommend you guys to watch the video of adrenergic nervous system, where I have discussed about adrenergic receptors. Knowing the location of adrenergic receptors and the effect produced on stimulation is very important, because you will not be able to understand anything in adrenaline if you don't know the location of adrenergic receptor and the effects produced on stimulation. So I will recommend you to watch the video of adrenergic nervous system before starting tomorrow's topic. Thank you for listening with patience.